everybody? This is Alec Bo with Code with Bo. Today we're going to be talking about abstract data types, what they are in the most basic form, so you can get started with building your own and use them as the foundations for your data structures. So let's go ahead and get into it. So an abstract data type is a type or class for objects whose behavior is defined by a set of value and a set of operations. And I'm just reading this right off here. And so pretty much what that's saying is an abstract data type is a user-defined data type, right? It's a container for data, and it typically points to the next container for data, right? It only mentions what operations are to be performed, but not how those operations will be implemented. So me personally, the way that I use my ADTs, that's the acronym for abstract data type, ADT. I typically separate the operations from the ADT itself, and I'll show you what I mean by that in a little bit. But whenever you get into working with classes, working with objects, working with your own data types, right, you learn about the principle of encapsulation. And encapsulation is combining operations on specific sets of data, right? And so that's what you use a class for. I was taught, and I continue to practice, separating the data type from the operations. And different languages give you different capabilities for that. Like in Python and Swift, you would use a class to define your ADT. But in C++, I like to use the struct data type because that is, a struct is for data only. A struct is a container of data. You define what the struct is going to be. You make your own abstract data type, and you make the characteristics of that data type inside the struct. Whereas if I was going to use a class in C++, that would also include functionality for it, right? And so that's kind of what I'm saying about I separate the functionality from the ADT, because an ADT should be able to function on its own. It should be able to be passed from program to program, regardless of the implementation. And that's the principle of loose coupling, right? And it makes your life easier because you're able to reuse data types, you're able to reuse code, you're able to build up your own little arsenal of tools, and that'll just make your life easier in the future. But okay, so what is like an abstract data type? So we're used to working with the primitive values like integer, float, character types, and we don't really think about how they work underneath. And so that's whenever we're making our ADTs, we should think of that as well. And I keep on talking about that principle of loose coupling, and that's something that you also want to think about, because being able to separate the interface from the implementation can not only allow you to reuse the code, but it can also allow others to reuse your code, right? And writing good code is about being able to logically break down what you're trying to do and pass those implementations and those interfaces off, and working in a black box. And a black box is one of the foundational principles of abstraction, right? You want to be able to abstract, and it's even in the name, abstract data types. You want to be able to abstract and give other users and yourself a black box which hides the inner structure and design of the data type. And so we're going to go into the most generic, most basic abstract data type there is, and that's going to be the node data type. A node is simply a container of data, and it's really the foundation for which you can build more complex data structures. And whenever you have a data structure made up of nodes, they are going to be connected to each other. They're going to point to each other, and that's going to be how your data structure is built up. And so we're going to go ahead and we're going to do implementations in C++, Python, and Swift, but we're going to get started with C++ first. And so like I was saying, in C++, I'm going to use the struct type node, right? And then we're just going to give it some data. So we're going to say int id node pointer to next. I'm going to put that right there. All right, so let's see exactly what we did here. So go ahead and write some comments. So we're going to define node struct. This is our abstract data type. Our abstract data type is the node. And so inside our node, we have an ID, right? So every node is going to be passed an ID. And then also we have a node inside our node. And what this node does is it points to the next node. And so that is how we're going to connect all the nodes together, how you would connect all the nodes together. This video is just going to be over the abstract data type itself, the node itself. And in future videos, we'll do an implementation with like a linked list or a stack or a queue or something where the nodes point to each other, right? And we can show the implementation of them. But right now, we're just doing the basic interface of the node. So this is how you would define a node in C++. And you can have, whatever data type, however many data types you want, right? String, value, and then we would just pass all these things to the nodes, and these are, oh, whoops. Let me see. Forgot that string isn't a, I need to include string. Oh, whoops, sorry. There we go. All right. So yeah, so it can really hold whatever types of data that you want, but this is a basic node implementation in C++. So let's go ahead and do one in Python. So we're going to open this up. We're going to open up, actually, we're going to do a new file. Alright, in Python we're going to define a class because they don't have structs in Python. And we're going to do the initializer, pass it the self parameter, and we're just going to put one data parameter self dot data is going to equal data, and then self dot next is going to equal none, and then there we go. And this is going to be a basic, let me see, got me going from language to language here, node ADT, then we're going to say data contained in node, and then this is going to be our pointer to next node. All right, so that's going to be the Python node ADT right there. So it's super simple, right? But I'm sure you can see how a container for data can be used as the foundational structures of your data structures and of your implementations. And then now we're going to go ahead and I'll show you an implementation that I have in Python. And so in Python we have in Swift we have this node right here. Oh my god. Sorry about that. And so in this we have this node right here. And so what this T does, right, in Python we define a public class name node. This T lets you pass in a node property value of any type. So it can take in any type. So this node in Swift is actually super generic, right? It really embodies that principle of loose coupling. It's not constrained to a specific data type, like how in the C++ we had where it took in the integer, where it took in the string. In Python, right, it's a dynamic language, so that one can also, I guess, take in any sort of data type too. But in this Swift implementation, we're specifically saying that we can create any property value, any value of any type, and then so you can see right here where we point to the next node, and this is just simply going to be an optional value. And then in this one we have a doubly connected node, right? And so a single connected node is just going to be pointing to the next one. Doubly connected node is going to be pointing to the next node and also the previous node. And these nodes are set to optionals because there may or may not be a next node, right? There may just be one node, and that's why whenever in the Python implementation that we saw beforehand, why the pointer was pointing to none, because there might not be a next node. But that's just the standard way you initialize it. But let's say we have this implementation right here, like how we have a linked list implementation. This is where you would define your operations for adding another node and setting the pointers to the node, whether it be to the previous one or next one. But this is going to be the basic Swift implementation right here. So yeah, that's the node implementation in 3 languages. So you can go ahead and use those as just base templates to get started. You can also build them up yourself, build your own nodes, use your own data types, really get your hands dirty with this so you can get used to working with ADTs, and then we can go further into building up data structures and then using algorithms on those data structures. And it's just part of the journey on becoming a full-fledged engineer. But yeah, that's going to be the video for today. If you have any sort of content you want me to make, just go ahead and comment it. As always, subscribe to my channel. Like the video if you got something out of it. If you didn't get something out of it, I'm more than welcome to criticism, because I too myself am trying to get better just like the rest of y'all. But as always, appreciate you tuning in to Code with Bo, and y'all